Next one is a wireless LAN. In that we are going to discuss about the PAN, personalized networks. So mainly the IEEE 802.11 having the architecture. In that the standard service set we have the distributed system. In that the access point we have the basic service set and then the selective data transfer rate and the distribution system. And mainly the wireless LAN in the sense IEEE 802.11 is a wireless connectivity. It's the architecture of IEEE 802.11. So mainly the STS we have that standard basic service set. We have the stations, station 1, station 2, station 3, station 4 is the base service set. And we have the access point with the connection of the distribution systems. And also having the station 5, station 6, station 7 we have, and then it will be connected to the distributed systems. It will be IEEE 802.11 LAN connectivity of portals. And IEEE 802.11 BSS have the MAC protocol and the physical medium specification for the wireless LANs, and the smallest building block basic services, that's BSS, and the number of stations and the MAC protocols, and they have the same, and competing for the access of the same shared wireless medium, it having in the smallest building blocks of the service networks. And maybe the isolated in the content of the access point with the distribution system to the connector of backbone of the entire network with the isolated connection of the backbone of the network. And the MAC protocol may be distributed or controlled by the central coordination of the access point. And BSS generally the corresponding to the all the cell and having the DSS with the content switching, wired network and the wireless connectivity of the networks. Mainly we have the extended service at the ESS. We have the 2 or more BSSs interconnected with the BSS system. Typically the DSS is wireless. The backbone can be used in any network and appears in the single logical LANs to the LLC. Mainly having the BSS, the base station, base service station having the BSS connectivity to the access point at the wireless medium with access through the IEEE 802.11 to the other stations. It's the basic one. And the access point having the logic within the station that provide the DSS. That DSS is service provided against the switching station. In IEEE 802.11 in the architecture we have the wireless LAN and wired LAN in the portal user we have. And then portal logic is implemented the devices is a LAN attached to the DS, and it will have the bridge or router we can able to interconnect the access point. And the services having the association, authentication, de-authentication, disassociation, distribution, integration, delivery, privacy, and reassociation. These are all the main major services in the telecommunication. In that we have the distribution systems, stations, and distribution system is mainly focused. Mainly the distribution system function is the association, and the disassociation, distribution, integration is the main part of the reassociation, also the main part of the service provided for the distribution systems. Station mainly authentication, de-authentication, delivery, and the privacy is the main usage of the stations, the main category of this mobile phone service systems. And also we have the IEEE 802 evaluation. We have IEEE 802.11 1997, the 2 Mbps data rate we have transferred, and then the 11.B, there's a 11 Mbps data rate speed with the clock of DSS, and 11.2.A having 54 Mbps rate. So we think of it's a 2 Mbps in 1997, and 11 Mbps, and then 54 Mbps with the optical fiber distribution system with 5 GHz range, huge data rate. And also having the OFDM of 2.4 GHz, and also having we are using the IEEE 2.11A, and with the G with the GHz is different. 2.11 this IEEE 2.11A having the 5 GHz range, and IEEE 2.11A let's G having that's a 2.4 GHz mainly. They are using the 54 Mbps data rate. And we have that 802.11n having the 600 Mbps with the 4 MIMO, multiple input multiple output system we are using with 2.4 or 5 GHz ranges we are mainly used. And 802.11p we are using 10 MHz range with the 5 GHz range. We have the wireless access point, and we are having the wave on the DS or G we are using. And 802.11 the TWS we are using for wireless communication. And also IEEE 802.11n we have using the very high throughput, and very high throughput range is around 6 GHz range we are using. That's why the GHz range we are using. That's why GHz mainly used. And Also, that's a protocol architecture. This is a LLC we are using, and we have the MAC layers. In that we have 2.4 GHz to 2.0 GHz range. We are using the MBPS data rate to title data 2.11a, 11 and 8.2.11b. We are using with that DCF of data coordination. We are using distributed coordination function with interlink with the logical control and that's point coordination functions. DCF we are mainly interlink with the other ports. This is the distributed coordinating function mainly using the CSMA technologies, and it transmit to the listening medium. And ideal and station mainly using the retransmission. No collision direction is available in the practical networks, and mainly and wireless network we can use in the range in the signal level for retransmission, and mainly delays in the primary schemes we can use in the interface of the space. We can use the point coordination function of the wireless communication. And then this is the point we are using in the response. We are using the coordinating the whole issues, and the PFAs we are mainly using. The SIF also is mainly important in the wireless communication. This the activity can find the difference in the picture.